Top 25 Senior Java Developer Interview Questions and Answers. A senior Java developer interview is not only about knowing Java syntax. Employers want to see whether you can design scalable systems, write clean and maintainable code, solve performance issues, mentor junior developers, and make strong technical decisions under pressure. At this level, you are expected to understand core Java, Spring Boot, microservices, databases, APIs, concurrency, cloud deployment, testing, and system design. In this guide, we will cover 25 important senior Java developer interview questions with strong sample answers to help you prepare confidently and sound experienced, practical, and job-ready during your interview. 1. What makes you suitable for a senior Java developer role? A good answer should show both technical depth and leadership ability. You can say that you are suitable because you have strong experience in building Java applications, designing backend services, working with Spring Boot, REST APIs, databases, and cloud-based systems. As a senior developer, you do not only write code, but also review architecture, improve performance, guide junior developers, and make sure the codebase remains maintainable. You understand the importance of clean code, testing, security, scalability, and communication with business and product teams. 2. What are the main features of Java that make it suitable for enterprise applications? Java is widely used in enterprise applications because it is platform independent, strongly typed, secure, scalable, and has a mature ecosystem. The JVM allows Java applications to run across different environments, while features like garbage collection, multithreading, exception handling, and strong memory management make it reliable for large systems. Java also has excellent frameworks such as Spring Boot, Hibernate, and Jakarta EE. For enterprise development, Java is valuable because it supports clean architecture, long-term maintainability, integration with databases, messaging systems, cloud platforms, and high-performance backend services. 3. What is the difference between JDK, JRE, and JVM? JVM stands for Java Virtual Machine, and it is responsible for running Java bytecode. JRE means Java Runtime Environment, which includes the JVM and libraries needed to run Java applications. JDK means Java Development Kit, and it includes the JRE Plus development tools such as the compiler, debugger, and other utilities. In simple terms, JVM runs the code, JRE provides the environment to run it, and JDK provides everything needed to develop, compile, and run Java applications. Developers use the JDK, while end users usually only need the JRE. 4. What are the key principles of object-oriented programming in Java? The four main principles of object-oriented programming are encapsulation, inheritance, polymorphism, and abstraction. Encapsulation means hiding internal data and exposing controlled access through methods. Inheritance allows one class to reuse or extend another class. Polymorphism allows the same method or interface to behave differently depending on the object implementation. Abstraction means hiding unnecessary details and exposing only essential behavior. In Java, these principles help developers write code that is reusable, maintainable, flexible, and easier to test, especially in large enterprise applications. 5. What is the difference between an abstract class and an interface? An abstract class can contain both abstract and concrete methods, while an interface mainly defines a contract that implementing classes must follow. Modern Java interfaces can also have default and static methods, but their purpose is still different. An abstract class is useful when classes share common behavior or state. An interface is better when you want to define capabilities across unrelated classes. For example, multiple classes can implement serializable or comparable. In senior-level design, interfaces are often preferred for loose coupling, dependency injection, and testable architecture. 6. What is dependency injection and why is it important in Spring? Dependency injection is a design pattern where objects receive their dependencies from an external container instead of creating them directly. In Spring, the IOC container manages object creation and injects dependencies automatically. This makes the application loosely coupled, easier to test, and easier to maintain. For example, a service class can depend on a repository interface rather than creating a repository object manually. This allows mock implementations during testing and makes code more flexible. Dependency injection is one of the main reasons Spring applications are clean, modular, and scalable. 7. How does Spring Boot simplify Java application development? Spring Boot simplifies Java development by reducing boilerplate configuration and providing sensible defaults. Instead of manually configuring everything, developers can quickly create production-ready applications using auto-configuration, starter dependencies, embedded servers, and externalized configuration. For example, with Spring Boot, you can create a REST API without manually setting up Tomcat or complex XML configuration. It also provides features like actuator, profiles, health checks, and easy integration with databases, security, messaging, and cloud platforms. This helps teams build applications faster while still following enterprise-grade development practices. 8. What is the difference between Spring MVC and Spring Boot? Spring MVC is a web framework used to build web applications and REST APIs in Java. It provides components like controllers, request mapping, validation, and model view handling. Spring Boot is not a replacement for Spring MVC. Instead, it simplifies the setup and configuration of Spring-based applications, including Spring MVC applications. With Spring MVC alone, developers often need more manual configuration. With Spring Boot, much of that configuration is automatically handled. In real projects, developers often use Spring Boot with Spring MVC to build fast, maintainable REST services. 9. How do you handle exceptions in a Spring Boot application? In Spring Boot, exceptions should be handled in a centralized and consistent way. A common approach is using @controller_advice with @exception_handler methods to catch specific exceptions and return meaningful error responses. For example, validation errors, resource not found errors, and internal server errors should return proper HTTP status codes and clear messages. This improves API reliability and user experience. I also avoid exposing sensitive technical details in error responses. Good exception handling includes logging, custom exception classes, structured error responses, and clear separation between business errors and system errors. 10. What is the difference between checked and unchecked exceptions in Java? Checked exceptions are exceptions that must be handled or declared in the method signature using throws. They are checked at compile time, such as IO exception or SQL exception. Unchecked exceptions are runtime exceptions that do not require mandatory handling, such as null pointer exception, illegal argument exception, or arithmetic exception. Checked exceptions are useful for recoverable conditions, while unchecked exceptions usually represent programming errors or unexpected failures. In modern enterprise applications, developers often use custom unchecked exceptions for business logic and handle them centrally to keep service methods clean and readable. 11. What is multithreading in Java and where have you used it? Multithreading allows multiple threads to run concurrently within a program, improving performance and responsiveness. In Java, threads can be created using thread, runnable, callable, or managed through executors. In enterprise applications, multithreading is useful for background processing, asynchronous tasks, batch jobs, file processing, message consumption, and handling concurrent requests. However, it must be used carefully because shared resources can cause race conditions, deadlocks, and inconsistent data. As a senior developer, I prefer using higher-level concurrency utilities like executor service, completable future, and thread-safe collections. 12. What is the difference between synchronized and volatile in Java? Synchronized is used to control access to a block of code or method so that only one thread can execute it at a time. It provides both mutual exclusion and visibility guarantees. Volatile is used for variables where changes made by one thread should be immediately visible to other threads, but it does not provide atomicity for compound operations. For example, volatile is suitable for flags but not for increment operations. Synchronized is stronger but can have performance costs. Choosing between them depends on the concurrency problem being solved. 13. What is the Java Collections Framework? The Java Collections Framework provides reusable data structures and algorithms for storing and manipulating groups of objects. It includes interfaces like list, set, queue, and map, and implementations such as ArrayList, linked list, hashset, treeset, hashmap, and concurrent hashmap. Each collection has different performance characteristics. For example, Array list is good for fast random access, while linked list is better for frequent insertions and deletions. As a senior developer, choosing the right collection is important for performance, memory usage, and clean code design. 14. What is the difference between HashMap and concurrent HashMap? HashMap is not thread-safe, meaning it should not be used directly in a multi-threaded environment where multiple threads modify it at the same time. Concurrent HashMap is designed for concurrent access and provides better performance than synchronizing an entire map manually. It allows multiple threads to read and update different segments or buckets safely. In modern Java versions, it uses efficient locking and CAS-based mechanisms. For applications involving caching, shared data, or concurrent processing, concurrent HashMap is usually a better choice than HashMap with manual synchronization. 15. What is garbage collection in Java? Garbage collection is Java's automatic memory management process. It removes objects from memory when they are no longer reachable by the application. This helps prevent memory leaks caused by forgotten object cleanup. The JVM manages memory using areas like heap, stack, young generation, old generation, and metaspace. Different garbage collectors are available depending on performance needs, such as G1, ZGC, and Parallel GC. As a senior developer, I understand that garbage collection reduces manual memory management, but poor object creation patterns, static references, and unclosed resources can still cause memory problems. 16. How do you identify and fix memory leaks in Java applications? To identify memory leaks, I usually start by monitoring heap usage, garbage collection behavior, and application performance. Tools like Visual VM, Java Flight Recorder, EclipseMet, or application monitoring platforms can help analyze heap dumps and find objects that are not being released. Common causes include static collections holding references, unclosed database connections, listeners not being removed, cache misconfiguration, and excessive object creation. To fix leaks, I remove unnecessary references, close resources properly, use bounded caches, and review object lifecycle. Prevention also requires good code reviews and monitoring. 17. What is Hibernate and how does it work with JPA? Hibernate is an ORM framework that maps Java objects to database tables, while JPA is a specification that defines standard ORM behavior. Hibernate is one of the most popular implementations of JPA. It allows developers to work with entities instead of writing repetitive SQL for basic operations. Hibernate manages persistence, relationships, transactions, lazy loading, caching, and dirty checking. In Spring Boot applications, Hibernate is often used with Spring Data JPA to simplify database access. However, senior developers must understand generated queries, N+1 problems, transactions, and performance tuning. 18. What is the N+1 query problem in Hibernate? The N+1 query problem happens when an application executes one query to fetch a list of records, and then additional queries are executed for each related record. For example, fetching 100 users and then fetching each user's orders separately can result in 101 queries. This creates serious performance issues. To fix it, developers can use fetch joins, entity graphs, batch fetching, or DTO projections. As a senior developer, I always review SQL logs, monitor query performance, and avoid unnecessary lazy loading in high-traffic APIs or batch processes. 19. How do you manage transactions in Spring? Spring manages transactions using the @transactional annotation or programmatic transaction management. The most common approach is using @transactional at the service layer, because business logic often involves multiple database operations that must succeed or fail together. If an exception occurs, Spring can roll back the transaction depending on the exception type and configuration. It is important to understand propagation, isolation levels, rollback rules, and transaction boundaries. As a senior developer, I avoid placing transactions in controllers and make sure external API calls are not unnecessarily included inside database transactions. 20. What is the difference between REST and SOAP? REST is an architectural style that commonly uses HTTP methods such as GET, POST, PUT, PATCH, and DELETE. It is lightweight, flexible, and usually uses JSON. SOAP is a protocol with strict standards, XML messaging, built-in error handling, and formal contracts through WSDL. REST is widely used in modern web and microservice applications because it is easier to build and consume. SOAP is still used in some enterprise, banking, and legacy systems where strict contracts and advanced standards are required. The choice depends on system requirements and integration needs. 21. How do you design a secure REST API in Java? A secure REST API should include authentication, authorization, input validation, proper error handling, logging, rate limiting, and secure communication through HTTPS. In Java, Spring Security is commonly used with JWT, OAuth2, or session-based authentication. Sensitive data should not be exposed in responses or logs. APIs should validate request payloads, prevent SQL injection, handle CORS carefully, and use role-based access control where needed. I also follow the principle of least privilege. Security should be considered from the design stage, not added only after development is complete. 22. What are microservices and what challenges come with them? Microservices are an architectural approach where an application is divided into small, independent services, each responsible for a specific business capability. Each service can be developed, deployed, and scaled independently. In Java, microservices are often built using Spring Boot and Spring Cloud. However, microservices also introduce challenges such as service communication, distributed transactions, monitoring, logging, data consistency, versioning, network failures, and deployment complexity. As a senior developer, I believe microservices should be used when the business and technical needs justify the added complexity. 23. How do you improve the performance of a Java application? Performance improvement starts with measurement, not guessing. I first identify bottlenecks using logs, metrics, profiling tools, APM tools, database query analysis, and JVM monitoring. Common improvements include optimizing SQL queries, adding proper indexes, reducing unnecessary object creation, using caching, improving algorithm efficiency, tuning thread pools, and reviewing garbage collection behavior. In Spring applications, I also check slow endpoints, external API calls, and transaction boundaries. As a senior developer, I focus on fixing the real bottleneck rather than making random code changes that may not improve performance. 24. How do you write maintainable Java code? Maintainable Java code is clean, readable, modular, testable, and easy to change. I follow principles like solid, separation of concerns, meaningful naming, small methods, clear package structure, and proper exception handling. I avoid duplicated logic, overly complex classes, and unnecessary abstractions. I also write unit tests and integration tests to protect important behavior. Code reviews are important because they improve quality and knowledge sharing. As a senior developer, maintainability matters because software usually lives longer than expected, and many developers may work on the same code base over time. 25. How do you mentor junior developers as a senior Java developer? Mentoring junior developers requires patience, clarity, and practical guidance. I support them through code reviews, pair programming, explaining design decisions, and helping them understand not just what to code, but why a certain approach is better. I try to give constructive feedback that improves their confidence instead of discouraging them. I also encourage good habits such as writing tests, reading logs, debugging carefully, and thinking about edge cases. A senior developer should help the team grow, improve code quality, and create an environment where learning is continuous. Preparing for a senior Java developer interview requires more than memorizing definitions. You need to show that you understand how Java works in real production environments, how to build reliable backend systems, and how to make smart technical decisions. Interviewers will often test your knowledge of core Java, Spring Boot, databases, APIs, concurrency, performance, security, and system design. They also want to know whether you can lead, mentor, communicate clearly, and solve problems calmly. Use these questions and answers as a strong foundation, but always connect your answers to real project experience whenever possible.